Hi, we are Group 9, and our project is on the investigation of crime rates in communities. Next. So the background and motivation for our project is that different social and economic inequalities have been shown to be highly correlated with crime rates, and more specifically, the most extreme ones, including assault, robbery, and homicide. And there are many different theories relating societal factors to crime, one of which is the social disorganization theory that points to the absence of societal structures such as schools or public libraries as a possible explanation for driving up crime rates. And so studying how such socioeconomic factors can affect crime rates in communities can help policymakers and government officials make better informed decisions to address these issues. Next. And the data set that we used for our project came from the UC Urban Machine Learning Repository. It was called Communities and Crimes Unnormalized. So some of the related works, some of the past studies have investigated relationship between income, unemployment, inflation, inequalities, development, etc., to different crime rates using MLR models in Romania. And a different study studied the relationship between socioeconomic conditions and policing characteristics and crime records in the US using different models such as the probabilistic binary logic regressions, exponential log linear regressions, and autoregressive integrated moving average regression models. And lastly, another studied the relationship between per capita income, income inequality, population, and presence of Black populations and urban crimes using OLS. And in our study, we'll be studying a handful of different socioeconomic factors and police interventions and their relationship with the overall crime rates. So moving on to the first research question, does police intervention have a significant impact on crime rates? And more specifically, how do the number of police officers, police budget, deployment of gang units, and the number of sworn full-time police officers in the field affect the crime rates? And what additional descriptive conclusions can we draw about the significance of this relationship? So the predictor and the target variables used, the target variable was the total crimes, which is the sum of violent and non-violent crimes per 100K population. And 3 of the continuous predictor variables were the number of police officers per 100K population, police operating budget per population, and sworn full-time police officers in the field per 100K population. And the 2 categorical variables, or it's the same categorical variable, but 2 different levels. And so the 2 dummy variables were the gang unit deployed part-time and the gang unit deployed full-time. And the overall null hypothesis is that police intervention has no significant impact on the overall crime rates, or that all of the regression coefficients are equal to 0. And the alternative hypothesis is that at least one of the predictors has a significant impact on the overall crime rates. And this is just an overall null hypothesis, and there will be additional ones following. So moving on to the methodology, I started off with an exploratory analysis of the X variables, and you can see from the right plot and the bottom 2 plots that all of the continuous variables have a significant amount of outliers, and so these would need to be addressed later. And I started off with a simple first-order term of all the predictor variables and plotting the residuals against the predictions amongst observing other added variable plots. I noticed that we didn't require any higher order terms. Next. But then observing the normality from the QQ plot of the residuals, notice that there was a high violation of the normality assumption where the Shapiro-Wilk p-value was less than 0.05. And so I performed a Box-Cox transformation, found that an appropriate value of lambda was equal to 0.5. So then the new transformed y is equal to the original y to the power of 0.5, or the square root of y. And this significantly increased the Shapiro-Wilk p-value up to 0.8286. So we have fixed the normality violation issue. And so with that transformed y, we performed a full initial model fitting. So in the blue box, you'll notice just the simple first order terms. And then in the red box, you notice all the continuous variables and their interaction terms with X24, which is the part-time gang unit deployment. And in the green box, you notice the continuous variables and their interaction terms with the full-time gang unit deployment. And the global F-test of this full model showed a p-value of around 1.77 e to the minus 7 and R-squared value of 0.17. Next. And performing the best subset algorithm on this initial full model and under various criteria such as the R-squared, AIC, CP, PRESS-P, etc. And in addition, due to the high marginal p-value for X11, it was suggested that dropping this variable will help the model be more efficient. And so the GLT test for dropping X11, which is the number of police officers in the community, showed a p-value of 0.1474, which shows that we may drop this variable at a significant. Next. And so that with that variable dropped and the new modified model, the influence plot was plotted, and the two data points, there were two data points that showed significance influence, and dropping the 2 points increases the tenfold cross-validation RMSE from 16.5 to 17.37, but it also increased the R-squared value from 0.09 to about 0.156. And so the increase in the R-squared value justifies the slight increase in the RMSE, and these two data points were dropped. Next. We also observed a high multicollinearity issue between all the three continuous variables, as you can see in the red box. And so these had to be addressed using ridge regression. Next. Yeah, and then looking at the lambda values for the ridge regression, lambda value of 0.06 was chosen. And this was because all the VIF values were decreased from about 9 to 16 to only 2, and all the coefficients were beginning to stabilize. So then the final model using this ridge regression showed that the police budget and the number of police officers in the field have a similar magnitude of linear impact, but the police officers had a much stronger interaction with the gang units deployed than the police budget's interaction terms with the full-time and part-time gang unit deployment. And while the model results are significant with low p-values, the low R-squared value suggests that it may be difficult to draw strong conclusions about the impact of police interventions in crime rates using this MLR model. Next.
So I did research question 2. So question 2 is trying to explore if violent crime rates across the U.S. communities can be predicted by a combination of multiple, socioeconomic variables such as income, poverty, employment, and lower family stability. Next page, please. So I have 1 response variables and 4 predict variables, and all of them are continuous. And my first predict variable is median family income. Second one is percentage of people under the poverty level. Third predict variable is percentage of people 16 and over in the labor force and unemployment. And the last predict variable is percentage of families with kids that are headed with by 2 parents. And my null hypothesis is the selected socioeconomic factors do not have a significant effect on violent crime rates. And my alternative hypothesis is at least one of the selected socioeconomic factors does have a significant effect on violent crime rates. Next page, please. The first thing I did is first order model. So the first initial the first multilinear regression model is listed below. Next page, please. The next step I did is the normality test. So from the QQ plot, from the left and from the right plot, which is a residual distribution, we can see that the data violates the normality assumption, and the p-value is less than 0.05. And the next thing I did is assumption checking. Also, from the 5 residual plot, we can see that the residual plot indicates no obvious violations of randomness and also no higher order associations. Next page, please. So the next thing I did is box cost transformation. The lambda I found is going to be 0.4, and I did y+1 here mainly because during the test there's one y value was equal to 0, and during the box cost transformation all the values has to be greater than 0. So I did y+1 to make sure I can do the test. Next page, please. So then I built the multilinear regression model 2. It's the same step as model 1. Next page, please. Also check the QQ plot and residual distribution again, and I find out that the transformation improves the normality of the data. Next page, please. Same thing I did for model 1. Residual plots also show improvement on randomness and linear association. Next page, please. I did stepwise and the best subset trying to figure out which predicted variables has a stronger associations with the response variables and which variables can be deleted from my equation. And from the stepwise and the best subset steps, and then both analysis indicate the best subset model multilinear regression 3 is equal to violent per population equal to family income plus percentage on employment and plus percentage of kids who has 2 parents. The next thing I did is multilinearity is trying to see if there's a strong interactions between all my 3 predicted variables. And from the left plot, I can see that there's pretty strong interactions, but from the right side, I did the VF test, and I can see that all the VF values are less than 5. So this analysis suggests that there's no obvious multicollinearity in the subset model 3, multilinear regression 3. Thank you. Next page. So based on the final model, we reject the null hypothesis. There are statistically significant associations between socioeconomic factors and violent crime rates. Higher unemployment is positively associated with violent crime, while a higher percentage of two-parent household is generally protective. Median family income has a weaker but still relevant effect. Thank you.
Okay, on to research question 3. So for research question 3, we use the question that education within a community determines the environment around it, which with these factors as shown below will result in an overall decrease in crime. In a different format, do the resulting variables shown below have a significant impact on crime rates? So for this question, the hypothesis and variables are shown below. So for my target variable, I used the violent and non-violent crimes per 100K of population. And for the predictor variables, I used all continuous, but two of them are related to education for people that are over 25 that are not high school graduates or are over 25 and have a bachelor's degree or higher. And for another predictor variable, I had police officers per 100K population. And the last two predictor variables are if homeless people are in shelters or on the street. And for this null hypothesis, it's basically just saying, does the education have a significant impact on the overall crime rate? As below. And then the alternate hypothesis, the level of education within the community has a significant impact on crimes with the designated factors. Oh, it has no. Okay, anyway. Anyways, the first methodology I used was just a regular standard like analysis where I got the plots and residuals and tried to see if there's any like uniformity or non-linearity. And as you can see, just from like these initial analysis, you can see that two of the plots are very skewed to the right and not showing that much normality. And we'll deal with that later. So for my initial fitting, I just did a standard linear regression model. As you can see below the plot of the QQ plot, and you can see that at the ends, it does not are very non-normalized. So we'll deal with that later. And as you can see, the data on the left. So for my transformation, I use a standard Box-Cox transformation. I use the different type of Box-Cox transformation, as you can see in the values on the left, with the best optimal lambda being 0.3. And within this Box-Cox transformation, I also logged both the homeless shelters and homeless people on the streets to deal with the right skewedness of those two plots. And as you can see in the future, that this really helped with the normality of my diagram. And from the previous initial fitting, you saw that the R-squared value was 0.25, but after the transformation, it is 0.266. And that's an increase, so that's good. And as you can see from the residuals, that three of the residuals got transformed in a better normality, as you saw from the R-squared also. And so after that, I did a fitting again with the new transformed values, and you can see from the global F-test that we had a good p-value of 2.2 times 10 to the negative 16. And as you can see from the plot also that it looks more linear. And to see if there's any like relationship between my 5 predictors, I did the multicollinearity test with the VIFs. But as you can see, they're all well below 5, so not much there. But as you can see on the right, there's the influence plot showing that there are 2 values that could indicate some like influence on the data, like outliers. But I did some checking, and the R-squared barely changes, so I just left them in. And so for the final analysis, as you can see, after all the so actually first I did the stepwise transformation to reduce the model to see if that could like help for like a better predictor on the crime rate of using education and crime rate. And as you can see on the residuals, once we did do that, the residuals looked very linear and good. So there is some indicator that it could be better. And so in my discussion, I put them together, so all predictors versus the 4 predictors. And as you can see, the values are shown here, whereas the R-squared value does decrease. But since the 4 predictors allow for more simplicity and predictive analysis, that you should use that for future endeavors. But anyways, the R-squared value is pretty low, so you can't really, it's hard to use it for future projects and researches because it's so low. But anyways, for the final discussion, you can see the best model that I chose. And from all the data, from the global F-test, we can reject the null hypothesis, which indicates that there is a significant impact on education on the total crime rate. And yeah.
For research question 4, I also did research of socioeconomics and demographic factors if they affect the crime rate. Specifically, I focused on police presence per capita, proportion of youth population from age 16 to 24, per capita income, and then the level of overcrowded housing. These are the variables I chose. For the target variable, I combined both violent and non-violent crime per population, and I chose police officers per 100K population, percentage of the youth population, per capita income, and then percent of persons in dense housing if there's more than 1 person. My null hypothesis is these socioeconomic factors if they do not have significant effect on the crime rate. My alternative if at least one of those have a significant effect on the crime rate. The initial fitting, I checked the scatter plot, and the third quadrant income had negative association with the crime rate, while other 3 had positive association. Looking at the residual plots, it shows some non-random patterns, and then BP test was less than 0.05, indicating violence of the non-constant variance assumption. Looking at the initial QQ plot, and then superiority test, the p-value was less than 0.05, indicating violating of the normality assumption. So I did the box cost transformation on Y. The best lambda was found to be 0.27. Next, please. Using the transformed Y value, I did the assumption check again. Residual plots showed a little bit of improved homoscedasticity, and the p-value was greater than 0.05, indicating the constant variant assumption was met. Looking at the normal QQ plot, the points are more closely aligned with the diagonal line at this time, and then superior test returned a p-value greater than 0.05, indicating the normality assumption was also met. After the assumption checks, I also ran more diagnostics. I did the influential plots, Cook's distance, BF beta plots. They showed few influential points. However, the model was already met even before running these diagnostics, so those points were retained in final analysis. Looking at VIF tests, they were all close to 1. The correlation coefficients were all less than 0.35, so there was no multicollinearity issue. After those, I also did the stepwise model selection to see if any of the predictors could be dropped. As a result, no predictor was removed, so all the predictors were used in the final analysis. Next, please. So I did the full Jesse test. The null hypothesis was rejected with very low p-value, indicating at least one of the variables had significant effect on the crime rate. 3 of the variables were significant, especially X22, the income per capita, had the strongest effect. However, the overcrowded housing was not significant at the level of 5%. Looking at the coefficients, the higher police presence youth population were associated with crime rate, while higher income were associated with decreased crime rate. Next, please. And in the k-fold cross-validation, RMSE, R-square, MAE value was found. R-square was pretty low, which indicates lack of exploratory power, and the magnitude of RMSE and then MAE needs to be further explored. Due to these limits, the further research with more comprehensive and higher data quality is needed. Thank you.